Round-robin scheduling algorithm. In the round-robin scheduling concept, the algorithm employs a time-sharing approach. This algorithm is similar to first-come, first-serve, FCFS, but with preemption. Each process is allocated CPU time known as a quantum time, which serves to constrain processing time, typically within the range of 1 to 100 milliseconds. Upon the expiration of the allocated quantum time, the ongoing process is temporarily halted and placed back into the ready queue. If a process completes its tasks within a CPU burst smaller than the time quantum, it promptly releases the CPU, allowing the next process in line to utilize it immediately. Conversely, if a process's CPU burst exceeds the time quantum, the process is temporarily suspended when the quantum time is reached. It is then requeued at the tail of the ready queue and subsequently executed after the next process in line. In a scenario where there are n processes in the ready queue and a time quantum queue, each process is granted a maximum of 1 divided by n of the CPU time during a single execution, with a limit of queue time units per CPU scheduling round. Importantly, no process experiences a wait time exceeding n-1 times queue units, ensuring a fair and efficient distribution of CPU time among the processes. How round-robin scheduling algorithm works. Let us consider 3 processes, P1 with burst time 6, P2 with burst time 3, and P3 with burst time 4, entered the ready queue at 0 arrival time. The operating system has set quantum time at 2 units of time. The process enters the runtime or burst time based on the process ID. The lowest process ID goes first. Once P1 enters the runtime, it runs for 2 units of time, and then it is moved from the CPU to the ready queue with remaining burst time at 4 per the quantum time frame. Then P2 enters for 2 units of time and leaves to the ready queue with the remaining 1 unit of time. Then P3 enters the burst time and leaves after 2 units of time to the ready queue with 2 units of time remaining. Now again P1 enters the burst time and consumes 2 units of time and leaves back to the ready queue with 2 units of time left. Then P2 enters the processor, then burst in 1 units of time. As the burst time is less than the quantum time, the processor moved the next high-priority process from the ready queue, which in this case P3, that is going to be burst in 2 units of time. Again, back to the ready queue to bring P1, which will be burst in 2 units of time, and then the ready queue is empty and all processes are completed. Round-robin scheduling algorithm. Example: this table demonstrates 5 processes that have arrived at the CPU. Ready queue at the same or different times. The process with the minimal arrival time goes first. If 2 processes arrive at the same time, as of our case, the process with the lower process ID is executed first. Since the first process, A, has a burst time of 2 units of time, the CPU will remain busy for 2 units of time, which indicates that the second process, B, will wait for 2 units of time, since it arrived at the same time of the first process. Process B enters running state for 2 units of time, then move to the ready state per the quantum time limit. Process C, D, and E arrives at the 3rd unit of time to the ready time. Process C enters running state, as it has lower process ID of processes D and E. Then process D enters the running state, and once completed process E enters the running state, all based on lower process ID. Then process B enters running state, again consuming 2 units of time to finish the job. So, the completion time for processes A is 2, B is 9, C is 5, D is 6, and E is 7. In this way, the waiting and turnaround times for all processes can be calculated. Turnaround time equals completion time minus arrival time. So the turnaround time for processes A is 2, B is 9, C is 2, D is 3, and E is 4. Waiting time equals turnaround time minus burst time, so the waiting time for processes A is 0, B is 5, C is 1, D is 2, and E is 3. The average turnaround time equals 4, and the average waiting time equals 2.2 units of time. The choice of scheduling algorithm depends on the specific needs of the system. First come, first serve is a good choice for batch systems where turnaround time is not critical, such as payroll processing, bank statement generation, email filtering, etc. Shortest job first is a good choice for interactive systems, where response time is important, such as web servers, database systems, graphical user interface, etc. Round robin is a good choice for systems with a mix of batch and interactive workloads, such as network routers, operating system kernels, embedded systems, etc.